right, let's take a look at this. We want to know if 4/8 is equal to 1/2. Yes, I have my handy dandy little fraction pieces. Okay, so we're gonna set it up, see if that's true. Yep, that's true. We're done. No, we can't be done. We can't be done because you don't have handy dandy little fraction pieces. So we're going to show you how to do this. There are actually about 3 ways, maybe more than 3 ways to do this. I'm only going to show you 2 because I'm going to hold 2 of them for suspense for later. Okay, so let's look at 4/8. And let's think about a number that will divide into both 4 and 8 evenly. Well, there's 2, and we can use that. But there's actually even a bigger number that divides into both of them. Yes, it's 4. So we're going to divide the top and the bottom by 4. So we're going to divide the bottom by 4 and the top by 4. When I do that, 4 divided by 4 is 1. 8 divided by 4 is 2. There is your 1/2. Perfect. Now notice, I have to do the same thing to the top and to the bottom. Whatever I do to the bottom, I must do to the top. And now think about what you're really dividing by. You're really dividing by 4 over 4. 4 over 4 is truly 1. So you must be dividing by a form of 1. That is how you simplify a fraction or reduce a fraction. This is called reducing. Reducing means to bring the fraction down to an equivalent fraction where you cannot reduce any longer. See, there's nothing in common between the 2 and the 1 anymore, so we can reduce any further. That's called reducing. And notice when you reduce, you divide by a form of 1. Let's now look at the following. Let's take 1/2. Maybe 1/2 wants to grow up. All right, we can make 1/2 look bigger. Okay, watch. I could actually pick a number, any number I want, and multiply it by the bottom. But if I multiply it by the bottom, I have to multiply it by the top. Because think about it. The only way you keep numbers the same is if you multiply or divide them by 1. Right? We know that. 6 times 1 is 6. It stays the same. So fractions look different. They look different, but they are truly equivalent if we divide by a form of 1 or multiply by a form of 1. So if we multiply the bottom by 4, we have to multiply the top by 4. And when we do that, we get 4/8. There it is again. There's your 4/8. We proved 2 ways that 4/8 equals 1/2. But this is called building a fraction. This is called building a fraction, where you multiply the top and bottom by the same number. But notice, the big important thing here is when you reduce, you divide by 1. When you build, you multiply by 1. So the big one here is 1. It has to be a form of 1. You either divide by a form of 1 or you multiply by a form of 1. 1 is very important when you're talking about fractions. 1 is very, very important when you talk about fractions, because you're either going to divide or multiply by a form of 1 to build or reduce the fraction. I want to talk about this a little bit. Okay. All right. Fractions that are equivalent, like this is equivalent to this, will really be on the same place on the number line, okay? But because they're equivalent, that makes sense, and I can see they're equivalent. Almost. I can now, I swear. See they're equivalent. Here we go. I can see they're equivalent. Okay. All right, let's take a look. A fraction is in lowest terms when I cannot reduce it anymore, so let's take a look at this, and let's see how we can reduce and build fractions. I think I'm going to start with building fractions. So let's do that, and then I'm going to prove it to you. Ay, ay, ay. My handy-dandy fraction pieces. All right, write 2/3 is an equivalent fraction with a denominator of 12. We can do this, and you have your workbook to follow. 2/3. You want it to have a denominator of 12. You want it to be an equivalent fraction. Here's how this works. You say to yourself, how do I get from 3? Look, I'm talking to myself again. This works so well in math. Okay. How do I get from 3 to 12? Well, now remember, the only thing we're allowed to do is either divide by a form of 1 or multiply. So you're only looking at those 2 operations. Well, to get from 3 to 12, I can multiply by 4. So I'm going to take this equal sign, move it a little because it's in my way. So I can multiply the bottom by 4, but if I multiply the bottom by 4, I have to. Yes, yes. Multiply the top by 4. Yep, you got it. Because, here we go. I have to multiply by a form of 1. So that is 2 times 4, or 8. So what we're just showing you is 2/3 is the same as 8/12. Now, of course, we could prove this. I know you're looking, and I know you're saying, please prove this, please prove this. Okay, I will. All right, because you know what I have to do now? Yes, yes, I have to do my handy-dandy fraction pieces. Okay. 2/3. I'm going to try not to drop them all over the place, but I can't promise you anything. Okay, 8/12. Okay. Oh, these 12 pieces are really small, but we can do it. Look, 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 look. I could probably prove it to you without getting them all over here. But, you know, I wouldn't want to do that because that takes the fun out of it. Okay, what do I got? 5. So what do I need? 3 more, hopefully. If it's not 3 more, I goofed. I better need 3 more. If it's not 3 more, I did this wrong. And, you know, that would look bad to do it wrong. Okay, here we go. Yep, there it is. So 2/3 is the same as 8/12. 1, 2, 3, 4, 5, 6, 7, 8. 8/12. All right, let's do another one. But remember, the whole key here is you're either multiplying or dividing. All right, let's take a look at number 2. All right, we have 1/2. We want to make it equivalent. You know what? I want to get that equal sign out of my way because you know I'm going to need that space. Okay, equal to, dirty board. A fraction whose denominator is 6. Well, again, the only thing you're allowed to do is multiply or divide by a form of 1. So, obviously, to get from 2 to 6, I'm going to have to be multiplying. So I have to think about 2 times what number is going to give me 6, and that number, of course, is 3. So I'm going to multiply the top by 3. The bottom by 3. If I multiply the bottom by 3, I have to multiply the top by 3. And I'm not going to use that x. I'm going to use that dot. Forget x's, huh? Okay. Again, I'm multiplying by a form of 1. That's extremely important. Whatever you do to the bottom, you do to the top, because you're multiplying by a form of 1. Because whenever you multiply a number by 1, it stays the same. So it stays equivalent. It looks different when you have a fraction, but it's still equivalent. That's why we show you these silly fraction pieces. Okay, they're really not silly. I love these fraction pieces. Okay, so 2 times 3 is 6. 1 times 3 is 3. So that shows us that 1/2 is the same as 3/6. I can prove that to you, I hope. You're going, yeah, I see it. No, you don't fully see it. You don't come on, you don't fully, let me have fun. You don't fully see it until you see the bars. Okay, so we have 1/2 and 3/6. Beautiful. All right, let's try number 3. And by the way, what we just did was called building fractions because we're multiplying to get to our new fraction. Okay, remember when you multiply, it's called building. When you divide, it's called reducing. So let's do number 3. Okay, let's get these fraction pieces out of the way a little bit. Okay, and let's look at this next one. This next one says 6/8 to an equivalent fraction having 4 as the denominator. Okay, so you want 4 as the denominator. So if you want to go from 8 to 4, remember the only thing you're allowed to do is multiply or divide. We're obviously getting smaller, so we're actually going to divide. So we have to divide by 2, because 8 divided by 2 is 4. So if we divide by 2 here, I'm going to use a different color. If we divide by 2 here, whatever we do to the bottom, we have to do to the top. Why? But because we have to use 1. 2 divided by 2 is 1, so you have to use that form of 1. Okay? So 8 divided by 2 is 4. 6 divided by 2 is 3. So we get 3/4. So we know 6/8 equals 3/4. Guess what I'm going to do now? Yes, I'm going to prove it. Okay, 6/8. Here's my 6/8. 1, 2. Oh, here's a lopsided 8. Doesn't really matter. 1, 2, 3. 4, 5, 6. I know this is your favorite part. Don't lie. 6/8. 3/4. And you just like the colors. 6/8 and 3/4, and they are equal. So now that is not called building. That is called reducing the fraction. Okay, because we divided by a form of 1. Realize why we're using 1 all the time. Because remember that the property for 1, multiplication property of 1, says when I multiply a number by 1, I get back the same number. Also, we have the division property of 1. When we divide a number by 1, we get back the same number. So it's got to be 1. So whatever you do to the bottom, we do to the top. Fractions look different, but they're exactly the same. They're equivalent. Okay. The next question says, using manipulatives, that's these guys, okay, reduce the following into lowest terms. Now, there's 3 of them up there. I'm going to do number 1 for you only using manipulatives, and then I'm going to ask you to do 2 and 3 by hand. Okay? So here we go. Here's number 1, 4, 6. If I'm reducing, the whole point of this is to explain really reducing. If I'm reducing, it means I want the numbers to be smaller than 4 and 6. Okay? So here's the deal. You want to break this up into less than 6. So you want to break it up into smaller portions. Well, we have 12s. Oh, 12s is bigger. We want a smaller number than 6. So we have thirds, we have halves, we have 8's too big, right? We have 4s. Let's see what you want to try. You want to try halves? Let's see if we can break it up into halves. Nope. Because if we have another half, it would be too big, so that's no good. So halves don't work. Let's try fourths. Maybe. Oh, no. Fourths don't work. No good. Okay. Let's try thirds. And this is using manipulatives. And then we're going to show you how to do it without using manipulatives. Because you don't have my manipulative. Oh, there it is. 2/3. So 4, 6 equals 2/3. That's what we know. Let's see why. Well, again, let's pick a number. If we're reducing, we have to divide. Let's pick a number that divides into both 4 and 6. Well, I can pick 2. Because they're even, so 2 goes into them. Okay? 4 divided by 2 is 3. 4 divided by 2 is not 3. That's the old math. Come on now. Okay. 4 divided by 2 is 2. 6 divided by 2 is 3. And there's your 2/3. And there you go. So to be able to reduce, you just need to pick a number that goes into both the numerator and denominator and divide top and bottom by that number. Okay? All right. So you're going to try 2 and 3. And then we'll come back and look at your answers. All right, let's see how you did. So we have 9/15. We're going to pick a number that goes into both 9 and 15. Okay, let's see. How about 3? We'll divide by 3, bottom by 3, and we get 15 divided by 3 is 5. 9 divided by 3 is 3. So 9/15 is the same thing as 3/5. No fraction bars. Take my word for it. 9/15 is better than is the same as 3/5. Let's try 6/12. Now, I have to tell you, we could use 6, and that's the best number to use because it's the biggest number. But I'm going to show you if you don't use 6, you're still okay. Let's say you look at the 2 numbers because sometimes you might have big numbers, and you go, I don't know, 2. I think 2 goes into both of them. And 2 does. Just watch. And when we divide by 2, the top and the bottom, which means we're really dividing by 1, we get 3, 6. The problem is you're not done because there's another number that goes into both 3 and 6. And yes, that number is 3. So we divide the top by 3, we divide the bottom by 3, and we get 1/2. And now we're done because there's no number that goes into 1 and 2, okay, without a remainder. Now notice, this is the cool part. If I divided by 2 and I divided by 3, 2 times 3 is 6. It means 6 goes into those numbers. Just kind of cool that if you, I don't know, that was just cool. I had to tell you that because you need to see that, okay? So I'm going to show you that I could have did this in one step had I divided by 6. The point of me really telling you this is sometimes you can't think of the biggest number. So you can just kind of go a little at a time. But if I divide by 6, I bypass all the steps. 6 divided by 6 is 1. 12 divided by 6 is 2, and I get 1/2. So either way I can get through to 1/2, but here I'm going through Chicago. Okay? All right. So that's 2 and 3. Now, the next set of problems, we want to first determine if they're in lowest forms, and if they are, great. If they're not, we're going to express them in lowest terms. So here we go. Lowest terms, simplest form, reduced form, all the same thing. It means make sure you go as far as you can where you cannot divide the top and bottom by the same number anymore. So let's take a look at this first one. In fact, while I write this down, which will be about 1 second, just take a look at the first one. Okay? And 4. Not 14. Let's try that again. 4. 14 over 20. Okay. 3/5. Can you find a number that goes into 3 and 5? Having trouble? Good. There is no number. So that is reduced. We're reduced. We're done. How about 9 and 10? Having trouble again? Good. There is no number. Reduced. How about 12 and 16? Don't worry about that negative. But how about 12 and 16? Yep, there is a number. That number is 4. You could have started with 2, but 4 goes into both of them. Okay? And disregard this negative, or just bring it down when we're done. 12 divided by 4 is 3. 16 divided by 4 is 4. Just bring the negative down. So it's -3/4. Now look here, and we are reduced. There's no number that goes into both 3 and 4. 14 over 21. There is a number that goes into both 14 and 21. That's 7. And when you reduce that, 14 divided by 7 is 2. 21 divided by 7 is 3. So we get 2/3. And notice we divided top and bottom by the same number. What we're really dividing by is 1. So I know I ask my classes all the time, what are we dividing by? They say 7. We're not dividing by 7. If we were dividing by 7, we wouldn't get the same number. We wouldn't get, these are equivalent, remember. They're the same number. They represent the same number. Okay, so be careful. All right. Sometimes it's hard to know what to divide by, so it's a good idea to make sure you're familiar with some factors. So let's do that. Let's take a look at the following numbers and get the factors of those numbers. All right. So let's take a look at the number 50. And this chart is in your workbook, so you can play along. Now, let me do the first one with you, so while I'm writing this down, you can do the rest. 50 means, all the factors of 50 means what times what will give me 50. So 50 times 1, 10 times 5, 2 times 25. Anything? 3, 4, 5, anything at 5? We got 5, 6, 7, 8, 10, 12. I think that does it. I think that does it for 50. So you're going to do that for the rest of them. 12, 200. 9, 7, 31. Okay, ready? 12. 1 and 12. There's a hard one. 6 and 2. 3 and 4. That's it. 200. 201. 200 times 1. 20 times 10. Power of 10. Remember that? 20 times 10 will be 200. 4 times 50. Oh, this is a big one. 5 times 40. Do I have to add more? 20, 10, 4, 52. 2 and 100. 7, 8, 10. 10 got 10. 12, 15. Nope, don't. I think that's it. Okay, 9. 3 times 3. Well, let's do 1 times 9 because I always start with that. 3 times 3. Up, but you don't write the 3 twice. So you only write it once. Okay, those are the factors. 7, 1 and 7. That's it. 31, 1 and 31. That's it. Okay. So if you're familiar with some factors, it might be easy to reduce those numbers if these are on the numerator or denominator of your fractions. Okay, let's look at primarily this and this. Notice, these are numbers whose only factors are 1 and itself. So 7, the only factors of 7 are 1 and 7. The only factors of 31 are 1 and 31, 1 and itself. These are called prime numbers. These are called prime numbers. Numbers that are not prime are called composite. Composite numbers are numbers that are not prime. So we have prime numbers and composite numbers. Sometimes it's a good idea to only have prime factors. So let's kind of get more familiar with prime numbers. This is not prime because 9 is not prime because it's got a factor of 3 here. Okay? So let's list all the, not all, let's list the first maybe 10 prime numbers. Okay, here we go. Remember, you can't start with 1. Got to go above 1. Is 2 a prime number? Well, if it's a prime number, the only factors would be 1 in itself. And yes, that would make 2 a prime number. So 2 is prime. 3 is prime. 4. 4 is not prime because it's 2 times 2. 5. 5 is prime. Don't say they're only odd numbers because there's not. There's an even number right there, right? 6. Nope. 6 isn't prime. 7. Yep. 7 is prime. 8. Nope. 9. Nope. 10. No. 11. Yes. What do you got? 5. 12. No. 13. Yes. 14. No. 15. No. 5 times 3. 16. No. 17. Yes. Oh, wow. That's a lot of 1, 2, 3, 4, 5, 6, 7. Okay. 18. No. 19. Yes. 20. No. 21. No. 7 times 3. 22. No. 23. Do I have 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. One more. 24. No. 25. No. 5 times 5. 26. No. 27. No. 9 times 3. We ever going to be done? 28. No. 29. Yes. So it's 29. Now, those are the first 10 prime numbers. Are there any other even prime numbers other than 2? Think about it. You thinking? Okay. There's not. And the reason is because all other numbers, since they will be even, 2 will divide into them. They will all be divisible by 2. So 2 is the only even prime number, and 0 and 1 are neither prime nor composite. Okay? All right, let's reduce these fractions and see what we get. These numbers are going to get a little bigger. Well, not particularly this one, but okay. 12/18. We want to reduce that. That means we want to divide the top and the bottom by the same number. Let's try to pick the biggest number if we can. I know 2 works. Okay. However, I think there's a bigger number. The bigger number, you thinking about it? Okay. The bigger number is 6. So we divide the top and the bottom by 6. Because remember what we're really dividing by is 1. So 12 divided by 6 is 2. 18 divided by 6 is 3. And we get 2/3. Okay. 45/18. Let's talk about this. This is the only one we've done so far in reducing that we've done like this. What do I mean by like this one? This is an improper fraction. So this one could be changed into a mixed number, but that's not what we're asking you to do. We're asking you to reduce it. Remember we said reducing is not the same thing as changing to a mixed number. Okay, so we're just going to pick the biggest number that divides into both of these. If you can't think of one, well, let's try 3, right? 3 goes into 45. Here's how I know. Remember this? Look, divisibility rules. Oh, try to say that fast. Divisibility rules. Okay. Sorry. 3 goes into 45 and 18 because 5 plus 4 is 9. 9 is divisible by 3, so the whole number is divisible by 3. Same thing with 18. Adds up to 9. If the sum adds up to a number that's divisible by 3, the number is divisible by 3. So that may help you get through some of these. Okay. We're going to divide the top and the bottom by 3. And that's 15. 45 divided by 3 is 15. 18 divided by 3 is 6. Oh, but I'm not done because I did not pick the biggest number. Let's try 3 again. Okay, because 5 plus 1 is 6. That'll be divisible by 3. And obviously that is. Okay, let's think about this. We'll do it again. It's okay. No sweating. No math anxiety. We're good. 6 divided by 3 is 2. 5 halves. Why did that happen? If we could divide by 3 twice, what could we have divided by once? Think about that for 1 second. Okay, time's up. Okay, if we divided by 3 twice, that means we really could have divided by 3 times 3 or 9. Let me just show you that would have left out a step here we wouldn't have had to deal with. 45/18. Had we divided by 9, had we thunk about it, just should have thunk a little harder. okay, we would have had 45 divided by 9 is 5. 18 divided by 9 is 2. Look how beautiful. That was easy. All right. It's a beautiful thing. Let's go to number 3. You know what? I'm going to use more space for number 3. So I'm going to erase some of this. Of course, reducing means you have to understand division. If you don't understand division, it's not going to be too easy for you. All right, number 3 is 150 over 280. 150 over 280. Notice I'm trying not to say the word and, me too, you know, because that means decimal. All right. That looks like a very, very big number. We can clean this up right away. You know how we can do that? We can get rid of those zeros. You know why? Because I definitely know that 10 will go into both of these because of the zeros at the end. And that will get rid of the zeros. 150 divided by 10 will clean out that 0. 150 divided by 10 is 15. 280 divided by 10 is 28. That seemed like a fair way to go. Now, let's see if we can reduce this. You know, I don't know here because look, 2 goes into that because that's even. 2 won't go into that. 3 will go into this because 5 plus 1 is 6, but 3 won't go in here. 4 will go into here, but not here. 28 is divisible by 4, but 15 is not divisible by 4. 5, nope, 28 is no good for 5. I think we're done. So it's 15 over 28. One step. Let's do 28 divided by 56. Now, we can play games all day here. We can reduce by 4. We could go on and on and on. But you know what I notice? You may not notice this. I notice this because I'm a math person. I notice that if 2 28s are 56, the 28 divides into 56, okay? 56 is divisible by 28. So I'm going to use 28. You might not have seen that. It's okay if you didn't see that. 56 divided by 28 is 2. Had you not seen that, you might have started with 2. You might have had to do 2 forever. So what? Okay? Wow, how many times would you have to have done 2 if you just stuck with 2? You want to think about that? How many times would you have to do? 14 times, because 14 times 2 is 28. You would have been here a little long. We could have gone to eat lunch, but that's okay. You would have got to your answer sooner or later. Okay, so that's 1/2. Okay, we're going to determine if the following sets of fractions are equivalent. Now, let's take a close look at this, because you might notice something. Okay. And 10 over 25. We want to know if these are equal. Well, let's think about this for a half a second. We know that to show 2 fractions are equal, we can either multiply by something or divide by something. Well, seems to be a little problem here. There's nothing I can divide by, that's a whole number anyway, that's going to give me 25. So maybe there's a better way. Well, there is a better way. If you can't see it directly to either build the fraction or reduce the fraction, you can reduce both fractions. So there's 2 methods for this, method 1 and method 2. Method 1 says reduce both fractions. So that's what we're going to do. We're going to take 16/40ths. I'm going to make a line here. We're going to take 16/40ths and we're going to reduce this fraction. Okay, so let's divide top and bottom by 8. Remember, we're multiplying we're dividing the whole fraction by 1, but dividing top and bottom by 8. That would be 2/5. All right, now let's do 10 over 25. 10 25ths. Okay, let's use 5. Ten divided by 5 is 2. 25 divided by 5 is 5. Ding, 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 ding. Yes, they are equivalent. So that is method 1. That is method 1. Let's do method 2 together, and then I'll let you do the other 2 problems. Okay, here's method 2. And you get to pick your own poison, okay? So here is method 2. 16/40ths, remember? And 10 over 25. All right. What you could do is say, I want to see if these 2 are equal. So I could say, are these two equal? I could put an equal sign there and test it. If I put an equal sign there, it is called a proportion. Okay, a proportion is a type of equation. It's called a proportion. If it was equal, it's be called a true proportion. In a proportion, what you know is the cross products are equal. What we mean by the cross products means that I can multiply. Oh, that was the same color. Sorry. Oh, look, I have all the same. Oh, they changed color. No, here's another one. All right. I can multiply diagonally across. So watch what I mean. I can multiply 16 times 25. And we're trying to see if it's equal to 10 times 40. 16 times 25, 10 times 40. Just going right across. 16 times 25 is 400. 10 times 40 is 400. It is true. So this is a true proportion. It means that this is a true statement. So I can cross, I call it cross multiplying. These are called the cross products, and this is called cross multiplying. Cross multiply. Anytime you have one fraction equal to one fraction, you have a proportion. One fraction equal to one fraction, you have a proportion. So that's another way to do it. That's method 2. And notice, once you cross multiply, the fraction is gone. You have no more fraction at this step. So I don't care how you do the next two, but see if the next two are equal to each other. Okay? And I don't care if you build or reduce, also, if you can. All right. All right, let's see how you did. I could probably think of 3 ways to do this. 4 ways. How about you? You're thinking you don't care about 4 ways, do you? Okay, here's what I'm looking at. I'm looking at 7/9. And I'm going to do this. I'm going to show you the different ways we're going to talk about. We're not going to do them all. And 21. Went a little crazy on you. Wrote that backwards almost. 21 over 27. We want to know if these are equal. And sometimes you can put a little question mark because you're wondering if those are equal. It's a question. Okay, watch. I could think about building 9 times 3 is 27. 7 times 3 is 21. So I built the fraction. Or I could reduce it. I could say 27 divided by 3 is 9. 21 divided by 3 is 7. I can see that these are equal. That's one thing I could do. Or what else I could do is I can reduce them both. Obviously, this does not reduce. If I reduce this one, I could divide by 3, and I would get 7/9. So it's equal. I've just shown you 3 ways already that that's equal. Another way is I could cross multiply. I could say 7 times 27. Wondering if that's equal to 9 times 21. This is 9, 49 carried a 4, 14, 189. And this is definitely 189. So we just showed you like 4 ways to show they were equal. So any way you slice it, these are equal. I don't care how you do it. Okay, you can either reduce both, you can build, you can do anything you want to do. Okay, but I just showed you 4 ways. Pick your own poison. Okay, let's do that. I'm going to show you just one way here, just one way. All right, otherwise we'll be here all day. All right, let's reduce this, and let's reduce this. If we reduce this, 8/30ths. I'm going to divide by 2. I'm going to divide by 2. I get 4/15. If this obviously doesn't reduce to 4/15 because it's 12/15. So you're done. These are not equal. Oh, I think I went a little crazy on you. Let's do that better. These are not equal. So these are equal. These are not equal. Equal, not equal. All right. Let's talk about another way you can factor something. Sometimes you need in algebra something called only the prime factors. So we already went over prime numbers. We're now going to go over how to take a number and get only the prime factors out of them. There's a lot of different methods. The method I like, because I think it's the simplest, is called a factor tree. You're thinking, oh, I remember this from like 1,000 years ago. Okay, I remember doing this with a rock. You know, no. Anyway, we're going to do the factor tree in 1 second. Now remember, prime numbers are not 0 or 1, so they cannot be part of your answer when you do the factor tree. So let's take a look at an example. Okay, Let's take the number 96. Now you see one on your screen. Okay, I'm going to do it different. They started with the factors 48 and 2. I'm not going to start with those factors, but I'm going to show you going to get the same answer. Okay, watch. Here's my tree. It's a growing. All right, here's what we're doing. You can start with any two factors. You can't pick one, but because one's not a prime number. Any two factors of 96. I showed you the example with 48 times 2. I'm going to do something different. I'm going to do 3 and 32. 3 times 32 is 96. Here's what you do. Every time you get a prime number, you circle it. That means that branch is dead. Dead branch. Now you go back to the number that's not dead, and you go any two factors of 32. Any two factors. Doesn't matter if you do 8 and 4. Doesn't matter if you do 16 and 2. So I'm doing a different example than you're looking at, but I want you to see it doesn't matter. So I'm going to do 8 and 4. If I do 8 and 4, neither of them are prime, so I have to keep growing. 8 could be 4 and 2. I'm going to keep finishing this part of the tree so I don't confuse you. 4 and 2. 2 is dead. It's prime. 4 is 2 times 2. Now that's dead. 4 is 2 times 2. So it doesn't matter how you do it. Now I'm going to count out my 2's. 1, 2, 3, 4, 5 2's. So that's 2 to the 5th power times 3. Don't forget your 3. And that is 96. And that is the answer to that you see on your screen as well. 2 to the 5th power times 3. I could prove this. Here's how I could prove it. 2 to the 5th. 2 times 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2 is 32. 32 times 3 is 96. And these are only the prime factors. 2's are all prime. 3's prime. That's the prime factorization of 96, and it's a factor tree. It doesn't matter how you start. You're going to end up in the same place. Okay, so I'm going to let you do 81 and 195. Okay, I actually wrote them because I wrote this one first and then I came back here. So this is the first one, 81. That's all good. Okay, 81. We're going to do a factor tree. Probably 9 times 9 is probably where you started. I don't know. It doesn't matter. We're going to end up in the same place. And neither one of them are prime, so I have to keep going. 9 is 3 times 3. So now that's a dead branch. This is prime. Dead branch, prime. Come over here, do the same thing. 3 times 3. So 81 is 3 to the 4th power, and you're done. That was so cool. Didn't matter where you started. You're going to end up in the same place. All right, let's take a look at 195. That's a little bigger. I think for 195, I definitely see it ends in a 5, so I'm going to do 5. 5 times 39. Now, you might not have thought of 5 times 39. It doesn't matter where you start. I'm going to circle the 5 because it's dead. 39. I know 3 goes into 39, so that's 3 times 13. Oh, I like 13. You know why I like 13? Because 13 is dead. Dead branch, prime number. 3 is also dead branch. Okay, so that's our answer. 5 times 3 times 13. Okay, so that's our prime factorization. So here's the deal. I know that these are all prime numbers, 5, 3, and 13. I know that when I multiply them together, guess what I get? Yes, I get 195. So that's it. You're done. Doesn't matter where you start. That's the point. And now we have only factors, only prime numbers as our factors. Okay? I'm going to give you something that you're going to think is so stupid. But trust me, it's important. All right. Because you're going to say, she can't really want me to do this. This is just so easy. Be grateful that it's easy. And then let's hope we learn something from it. Okay. You got 3 plus 4 plus 2 over 8 plus 5 plus 2. I want you to just simplify that. Yes, I'm serious. And then 3 times 4 times 2 over 8 times 5 times 2. This is number 2. And then 3. 16/40. We want to simplify all 3 of those. So you're going to take a second to do that. All right. This is 9. This is 15. So we get 9/15, which I can reduce. I divide the top by 3 the bottom by 3, because I'm really dividing by 1. 9 divided by 3 is 3. 15 divided by 3 is 5. We get 3/5. That's the answer to that question. Let's look at this question. 3 times 4 is 12, times 2 is 24. 8 times 5 is 40, times 2 is 80. That's 24 idiiots. I'm going to now reduce that. I'm going to divide by, I'm thinking 4. 4. I get 6. I could have did something bigger. Didn't think about it, sorry. Well, I could divide by 2 now, top and bottom by 2. It's okay, doesn't matter. I'm going to move this over. Divide by 2. Oh, why didn't I think of 8? 4 times 2 could have did 8. Don't know why I didn't think of 8. Sorry. That's 3/10. And then this last one was 16/40. And the biggest number that goes into both of those is 8. I'm not going to screw up twice in a row, because I'm really dividing by 1. 16 divided by 8 is 2. 40 divided by 8 is 5. What'd you learn from that? Nothing. I know. Wait, I'll show you. I wonder if I would get the same answer if I did this. Watch. 4 goes into 4 once. 4 divides into 8 twice. 2 divides into 2 once. 2 divides into 2 once. On the top, I have 3 times 1 times 1, or just 3. On the bottom, I have 2 times 5, which is 10, times 1, which is 10. Oh. That's a little quicker, wasn't it? Let's see if this will work here. Let me see. 2 goes into 2 once. 2 goes into 2 once. 4 goes into 4 once. 4 goes into 8 twice. That gives me 3 plus 1 plus 1, that's 5. 2 plus 5 is 7. That gives me 5/7. Oh, it doesn't work there. Only works here. This is called reducing. It's another way to reduce, okay? And it works when everything's attached by multiplication, but it doesn't work in addition or subtraction. So I can reduce factors. I can reduce factors, not terms. That's what's really, really important. Now you're thinking, what the heck did this have to do with that? I'll show you. This is what we've been doing the whole time. You just didn't know it. We've been hiding it from you. This is what really has been going on. Watch. If I divide by 8 here, 8 over 8, what's really going on is this is 8 times 2. This is 8 times 5. And you've been reducing out the 8. You just didn't know it. You just didn't know you were doing that. Look, 2/5. 1 times 2 is 2. 1 times 5 is 5. So the whole point here is you can reduce factors, not terms. That's like a drum roll. Okay, you can reduce factors, not terms. Everything can be attached by multiplication, but it cannot be attached by addition or subtraction. That's really, really, really important. Okay, why do I care? Watch. I care. I really care. Here's why. Let's reduce 7D, not 7D, 7D over 21. Well, I'm going to start reducing this way instead of showing every single step. Watch. And you can slow me down if you think you need me to. We're going to pick a number that goes into both 7 and 21. The biggest number is 7. 7 goes into 7 once. 7 goes into 21 3 times. My answer is 1D, or just D, over 3. Done. Can I prove to you that they're equivalent? What I'm saying is that 7D over 21 equals D over 3. And I'm telling you, I can prove to you that's true. Let me prove it. I can prove it a couple ways. I just thought of a way right now, but I could prove it like 5 ways. But I'm going to prove it with a number. Okay? Let's say D is, I don't know, 4. It doesn't matter. Okay. If D is 4, then I have 7D, or 7 times 4 over 21, equals D, which is 4/3, right? That's 28 over 21 equals 4/3. Well, how can I prove that this is true? I can just reduce this if I'd like, or I can build it. Doesn't matter. But if I reduce this, 28 over 21, I'll divide by 7. I'll divide by 7. and I get 4/3. So we proved it. But there's so many different ways to prove this is true. I could cross multiply. I get 21D. I get 21D. I could prove this all day. It doesn't matter. All the point is that if I'm attached by multiplication, I'm allowed to reduce. So this is attached by multiplication. I'm allowed to reduce. So let's do some problems, okay? Let's make them harder. Here we go. Remember, 1D is the same as D. All right. Oh, I'm feeling good here. 8a squared over 6a squared. Okay. For now, until we get really good at this, which we will, for now, we're going to write out the factors. I'm not going to write out the factors of the numbers, just of the letters. So I'm going to write this as this. 8 times a times a. I'm going to write this as 6 times a times a. Okay, you ready? Here we go. I'm going to reduce the numbers. We have to pick a number that divides into 6 and 8. The number that divides into 6 and 8, the highest number is 2. So 2 goes into 6 3 times. 2 goes into 8 4 times. But now, anything divided by itself is 1. So good night, good night, good night, good night. So on the top you have 4. 4 times 1 is 4. On the bottom you have 3. 3 times 1 is 3. So the answer to this question is 4/3. Done deal. Pretty cool. And remember, here's why we can do it. Because this was attached by multiplication. If that said 8 plus a squared, we couldn't have did any of this. But it's because they're attached by multiplication. And there's probably a quicker way that you could have saw, possibly, a squared over a squared. I could have reduced that right away because they are exactly the same. I could have reduced that right away. But I just wanted to show you what it means. I could have took these right out because they're exactly the same. But remember, when you reduce to write a 1, a goes into a once, a goes into a once. Okay? Out of here. All right, take a look at this one. Well, first let's look at the numbers. And the number, I could write this out, but I want to show you something first. I could write it out just like I wrote this out. But before I do that, I want to show you something first. Okay? There's no number that goes into both 3 and 5, so I can't reduce the numbers. And notice, the only reason these reduce is because they're exactly the same letter. These are different letters, so I cannot reduce them. So I'm done. Cannot reduce. This cannot reduce. So it's simplified. Or for short, you can say no can do. Okay? Because you cannot do this problem. Cannot simplify. It is simplified. Okay, let's look at this one. This is a beauty. I'm feeling good about this one. 10x squared y. Okay, over 4y squared, divided by or over 4y squared. Okay, I'm going to write this one out because you notice that they're y's top and bottom. So I'm going to write it out so you can see it. This is 10 times x times y. Because remember, the exponent only works to its immediate left, so the exponent has nothing to do with the 10. Okay, 4 times y times y. All right, here we go. Let's go to numbers first. You have to pick a number that divides into both 4 and 10 without a remainder. That number is 2. 2 goes into 4 twice. 2 goes into 10 5 times. 2 goes into 4 twice. 2 goes into 10 5 times. Now we'll go to the letters. Good night, Y. Good night, Y. Make sure you write those ones there. Okay, because it's going to matter if this was a different type of question. All right, so we have 5 times x times 1. The x's stay because there's no x's on the bottom. That y stays because there's no more y's on the top. Okay, so this is 5. X times x is just x squared, all over 2 times y, which is 2y. So that's the answer to your question. Okay, that's the end of reducing fractions. Next will be multiplying fractions, and that's way too much fun. Hey, I have different manipulators for that one. All right.